Yeah, ladies and gentlemen, well, warm welcome to my presentation of new electric axle and battery systems in battery electric vehicles. As Fernando said, I'm working at AX Solution, and I will give you a very short introduction about my company. And the second chapter will tell us about our new e-axle drive system, especially the 800-volt e-machines. Then I will give you some overview about energy storage, and I have a system consideration, a simulation of our e-machine with battery system and power electronics. And I will end my presentation with a conclusion. EX Solution, a company with around about 100 people, located in Berlin, was founded 2018 from the Hofer Powertrain organization, has some very exciting years with Chinese joint ventures. And up to 2021, we are now at the Bosch company and working in Berlin with our small production line. You can see it here. And the main part today is to support the Bosch colleagues with low volume production parts, special production parts, especially when the customer is using special interfaces, special design optimization of his motor. We can help the people, we can help the colleagues from Bosch with that, with our smart production line. And this production line can produce in maximum of 15,000 pieces every year. And if the customer choose the existing variant we have on stage, then we can deliver this sample up to 1 month. The complete system is a real automotive manufacturing execution system. And today we are calling the ISO 146544. Yeah. If you have some questions about EX Solutions, please contact me. My address you will see in the end of the presentation. Now let me start with the special technology way of e-machines, 800-volt power electronics with silicon carbide technology, battery systems, which are well known today. Also a look into the future of the new solid state technology. And for that, I will start with overview of the e-machine. I think they are well known. Very good overview. You can see the existing parts of e-machine, this asynchronous machine, the different variants of permanent excited synchronous machine. Also today, very well known, the external excited synchronous machine, and from time to time, I think not in the automotive sector, not for the automotive sector interesting is the synchronous reluctance machine. In this presentation, I will take the main view of the permanent excited synchronous machine, magnets inside the machine, and if you can see in the comparison of these small diagrams, also with the best configuration, speed over power. That's the reason why we go in this direction of design of 800-volt machine for EX Solutions. A short overview about our existing variants. So the main machine is our EM 220 154-800. That means the active outer diameter of the stator is 220 millimeter. The length, the active length of the stator, 155 millimeter. 800 volt indicates the working with the 800 volt system. And for that, we have two main variants. They're also available in different lengths with the maximum power in the peak performance area of 300 kilowatt and 450 newton meters. Continuous with the half of them, 150 kilowatt, 250 newton meters. And actual The maximum speed is 3000 RPM, but we are working on to get more than 16,000 RPM. The other points you can also get in the information sheet, which are available on our website. Then the longer version, 205 millimeter active length of the stereo, has the peak performance of 360 kilowatt, 720 Newton meters, and with the half of the performance of continuous performance and also from the torque side. And we have maximum operation speed 10,000 RPM. Especially for agriculture applications, we designed an ePTO variant. PTO means power take-off, with which are auxiliary drive systems usage in construction machines, in agriculture applications, and the E means it's electrified. So we are able to give a peak performance 160 kilowatt for 710 Newton meters torque, and around about also the half of the continuous performance, 90 kilowatt and 200 Newton meters. This product is completely new because it's now the time to change all the diesel aggregates in the agriculture and construction machines to electrify it. And that machine is in very high interest today in this non-automotive area. From the transmission side, we are the in-wheel hub motor axle flux machine are special applications. We are not produce and development this one. Today, it's possible to use our machine in the 3-in-1 solution standard. That means integration of e-machine, of power electronic and transmission. So with our partners, especially from Bosch Rexroth, we can provide you a complete axle drive system with these 3 components. And the trend is also, especially in the automotive area, to use higher speeds for this application. What we also see, especially in non-automotive applications with 2, 3 different working areas, are standard 2-speed gearboxes for high-performance cars, or we have 3-speed gearboxes for the commercial vehicle area. And we're also thinking about uninterrupted transmission. That's the reason that you have not the feeling when the machine is going in one speed to another one. So, but this area is not usable and is not necessary for non-automotive applications in the future. On the power electronic side, I provide you in this picture the well-known 6-pulse bridge. Today, in the standard application with IGBT semiconductor elements, and with the normal control of the machine, the power control, the speed control is well known. Vector-oriented control software will give the best sinus ideal current inside the e-machine. But what happened in the future with this kind of semiconductors? And for that, we, Bosch and EX Solutions, make a study with the 3 most important or the 3 most interesting semiconductors. The well-known and the automotive standard today, the IGBT. Comparison to that, the silicon carbide components, which are today also going to be a standard now and in the future. And also look to also in discussion for automotive applications, the variable gallium nitride application, which has the highest efficiency but at the highest frequency, that's for sure. But and we have a smaller system side, and we make this kind of spider diagram, and you can see in the area of efficiency power density, high voltage usage, robustness, easy production, and price performance, that today the IGBTs have a big advantage because they are well known. They are over 30 years now in series production. And for that, they have some big advantages in this area. And the silicon carbide will give us a higher power density than the IGBTs in the future for sure, and also a better efficiency. Much better for that only can be usage can be reached by gallium nitride technology. But you see, we have some issues with high voltage usage and for all in this area of automotive with the robustness side. So the view of Bosch and our idea in the future will be that the IGBT will use in the normal applications like 400-volt inverter, and the SiC will usable in the high performance in the 800-volt area. For overview, what are the big difference between the MOSFET or IGBTs has the same configuration from the length of the semiconductor plate to the SiC MOSFET and to the gallium nitride MOSFET. And one point is that we have a better dielectric strength of the SiC MOSFET coming from 0.3 megavolt for the centimeters to 2.8 megavolt to centimeters for the SiC MOSFET. And also the switching frequency for the SiC components could be in the area of 100 kilohertz. I think we don't need this high number of 100 kilohertz, but for example, and that is also usable today in telecommunication applications, you can have a switching frequency of the gallium nitride semiconductors up to 10 megahertz. And that's the big advantage for that, but we have seen it in the spider diagram before. The robustness for the silicon carbide is much more better. And also the thermal robustness is much more higher than IGBTs. So the temperature could be up to 300 degrees instead of 150 degrees of the semiconductor plate. So for that, we announced the silicon carbide MOSFET for 800-volt applications and the silicon MOSFET or also the IGBT in the area of 400-volt MOSFETs. Then let us have a close look to the battery systems, the energy storage. So I will give you an overview about the CATL concepts and comparison to that. And I've made also a spider diagram to give you an overview about the advantages and disadvantages of this kind of technologies. So in the first step, we have a comparison between the NMC and NCA technology and the LFP. And NMC technology you can see here. The big problem in the past was that we have high numbers of cobalt, of mangan, and manganese, and nickel, and that will be reduced from the cobalt and manganese side up to lower than 10% for this component. So we have not such a critical component composition like the first NMC 111 in one part of all part, and you can see 8 part of nickel and 1 part of the other one. The NMC technology, nickel, mangan, cobalt oxide, that's the complete name for that, has in all areas a good condition like energy density, like fast charging, like power delivery, lifetime price. security, and available. Yeah, available is a little bit critical because of this kind of materials. But this kind of technology, also next one, are the standards today. In comparison to that, today we have, for your information, yeah, around about 250 watt-hour per kilogram with this kind of technology. With higher energy density and better power delivery, the NCA, nickel, cobalt, aluminium oxide, is much more better in this area. But from the security side, we have also some issues. The big advantage of NCA are the energy density is much more better, like the slide diagram shows. So we talk about 320 watt-hour per kilogram for this kind of technology in the actual applications. And today, customer is Tesla, for example, and the main supplier is Panasonic. You know it if you are insider. Yeah, and the most discussion for the alternative to have no cobalt, no nickel, no mangan inside is the new LFP, lithium ferrite phosphate technology. Big advantage. We have availability, good availability of the materials, high security, low price, high lifetime. The only big disadvantage are the power delivery and the energy density of this kind of technology. But from the charging time, we have better charging times than the other two existing technologies. So the energy density, the low energy density and low power delivery will have some new ideas to go in new battery designs. So today, you see also the energy density is not much higher. It's lower than the NMC. It's 190 watt-hours for every kilogram. But from this position out, it's possible today to go in the cell-to-pack technology. So CATL, for example, is working very intensively on that to reduce the volume. So you will not use longer special modules. You will pack every battery in one directly module. So that's the reason why you can reduce the volume up to 20%. When we go in comparison to the existing technology today, it's an older one. It started at 2015, and there was prognosis to 2030. You will see today, and that's true, I think, we have in the main technology with over 50% the NMC technology inside the cars. LFP is coming. It's coming more than this prognosis will show, I guess. NMC will be constant because for higher performance cars, it's very realistic also in the future. And other technologies will go on the market. So there was information about solid state technology, which is now over 10 years old. That the first suppliers are pronouncing now that are in serious production in the next years. And sodium ion will be a very interesting alternative to lithium because sodium is much more cheaper than lithium and available in enormous mass on Earth. So that I have looked for actual prognosis from racing energy that shows us what happens in with the batteries. This kind of picture looks like the picture before. That the main part is the existing high nickel battery demand with NMC and NCA technology. We have a good development of LFP technology, and the sodium battery prognosis are in small parts, but not much more higher in the future. So the LFP could be the most important thing. And if the ASSB, all solid state batteries will come. So the first supplier said the serious start begins at 2027. Then also the solid state battery will remove the existing technology of high nickel battery demand. That's the prognosis up to 2040. Yeah, all these components, battery system, power electronic, e-machine transmission will now shown in one activity, in one simulation of a system. So at first, I will have a short discussion about the WLTP cycle. Then I give you overview will show you a MATLAB Simulink model about this one and what are the results of this simulation with new components like silicon carbide inverter, 800-volt e-machine, and the existing battery technology NMC. At first, I will show you some self-testing. So I drive also a smart, especially in the Berlin area. It's a very good car, electrical smart for sure. And there is the WLTP cycle is well known with his 4 different working areas from the low speed area up to high speed, like using on the highway. And for that, I've made my driving profile when I start at home to my working place. And it looks, yeah, not so similar like the WLTP, but it shows also some different areas from lower driving, higher driving, and also some parts which I'm driving on the highway. And when I have the comparison of the energy usage of the WLTP with my special driving cycle, you can see on the blue line, it's the WLTP cycle energy, which I have, which is the same consumption when I drive with my Berlin cycle. And that's the reason I think the WLTP cycle could be a very good comparison for electrical cars to have a clear picture what are the energy usage of this kind of machine instead of other ones. And for that, we make a simulation with this kind of WLTP with a car. So we have put a standard car. I think it was a Volkswagen ID3 was mentioned, and an NMC battery of 442 kilowatt hours, and the new electrical axle drive system 800 volt, and the new Bosch silicon carbide inverter for this kind of simulation. So the input is the driver, the WLTP cycle, and we will have a look what happens with the energy consumption. And our improvement was also have a few on transmission, e-machine, and power electronic. For that, we make MATLAB Simulink model for that we have a clear picture of what happens in the different component areas. And especially for this area, when you drive to the highway, to the Autobahn, we will have a look to this short piece of the cycle and see what happens with the system. So we have, for example, the motor torque on this picture, and you can see there happened something in the area of 85 seconds, and that shows us that I will also have a comparison between one step and two step gear. Yeah, you can see it here what happens with this area, and the process was to have a ratio difference between 11.8 with the normal one-step gear, which will also used in the higher speed, and the decision with the two-step gear to have a switch between 11.8 to 6.5 after 85 seconds. And for the first, the efficiency diagram, you can see that's the system efficiency. What happens shows us the normal cycle. Also, the recuperation phases are there. There are no efficiency measurement happened, but you can see on this area that there was a significant increase of the efficiency when we go in the step from 11.8 to 6.5 gear ratio. And also, the better 800-volt system with lithium carbide gives us better efficiency of 0.092 efficiency with this new machine and power electronics in addition. And to show you what happens, it's very interesting to have this kind of efficiency diagram. So all the dots shown us the different working areas of the WLTP cycle for one step. And when I can use the two-step transmission, you can move all the dots on the high motor speed to the lower motor speed. And the effect is that you have at one point to reduce to increase the efficiency, to reduce the consumption, energy consumption from the battery side, better than 6%. And with usage of 800-volt and stick silicon carbide inverter, you can have additional better efficiency of 3% in this area. And in the conclusion, to see the WLTP cycle with the different two-step gearboxes, we have in some energy consumption reduction of 10%, which is for this kind of simulation in the first step very interesting. And in the conclusion, I can give you also an overview what will happen with the price side, or what can you save on cost when you take a two-step gearbox with new power electronic and new electrical machines. So I'll come to my conclusion. And at first, the e-axle, that I think that's no discussion about it, that the permanent magnet synchro machine will have the best efficiency in the automotive solution also in the future. But there are also the alternatives like the external excited synchro machine and the induction motor. They have today very good alternative technologies for this application. And especially when the price of the magnets will increase, I think these two parts of electrical machine can be a good alternative in the future applications of automotive cars and also of non-automotive applications. And the new standard for 800 volts will be the lithium carbide inverter technology, but be sure that this new technology will also have an effect of the isolation technology of the machine, because we have much more higher DU up to DT. The raise of the voltage is much more higher than in the 400 volt IGBT technology. So you must have also to have a look to the e-machines for the isolation materials and for the isolation strategy. And I think in the future, especially for cars, they have more long range and more high speed or autobahn parts. It could be interesting, and we have some examples that already exist with a two-step gearbox to think about a more step gearbox and 800 volt technology, which I'll show you in my simulation example. Yeah, battery system. I think the LFP technology as a cobalt-free alternative will take part in the market in the future with the most parts. Also from the economic side, it makes sense to do it. The sodium-ion solid-state technology will come in series not before 2027. That's what the supplier said. And especially the battery, everything is talking about recycling. I think in the next step of the life of battery system, the second life is very interesting for them. That means usage of old batteries from automotive, from passenger cars, and then the second life as a storage, as a static storage for save the energy from houses and so on in the future. And that will, the second life will have also 10 to up to 20 years for such kind of battery system. So I think the recycling will be very interesting in 20 years early, earliest. Yeah, and in my system solutions with the optimization of the axle system, I show you example of two-step gearboxes with silicon carbide inverter, 800-volt technology. And that brings us to the idea to have a downsizing of the machine on one side, but it offers also to save 10% of energy that you have also a cost saving effect. So today with 2 kWh saving, we talk about to reduce the battery system on 2 kWh to reduce the cost of 240 euros for NMC technologies. Assumption is 20 kWh for 100 kilometer today and 120 euros for 1 kWh for battery storage. I heard new numbers. The numbers today will go more in the direction of 17, 80 euros for batteries, but in the NMC and NCA technology, today the prices are more than 130 euros for 1 kWh. So then I will come to end. I hope I can show you some insights about our activities to get better machines in 800-volt technologies, and I'm open for your questions. Thank you very much.